and thanks for being here at the panel. So before taking the questions from the audience, so if you're online, it's time to ask a question. It's monitored, and we'll take some questions from the audience as well. But I had sent a first initial questions to the speakers just to bootstrap the conversation. I think it has been a bit discussed already, especially in some of the presentation. But let me just say it again, and we'll see if some people want to react on this. So my first question was, because we talk a lot about LLMs, what capabilities do large language models currently provide to enhance the functionality of social robots or social agents? And what are their current limitations or gaps in this context? So it has been a bit addressed by some of you, but let's have maybe just a quick overview of each speaker's answer, and then we'll take the question from the audience. So who wants to start?
I gave a whole talk on that.
Yeah.
I mean, is there anything else beyond that what I didn't say? Like, it's so the work I presented was like was done 2 years ago, and some have been improved since then, right? So now we have models that can actually do some turn taking and that you can actually interrupt with the O1 and the voice model, but it's still not there yet. So the conversations still feel very superficial. And also, for some reason, flirty, which is not what we want these conversational agents to be. I mean, of course, there are some use cases for it, but it's. I think that there still needs to be much more development into, especially the long-term memory. So that's what I didn't go into. But like, if you're going to have these robots in the people's houses, you want to actually remember previous conversations, but you want to don't just like save those information in a database, to be able, because like, if you do that, then you're not going to be able to remember things. You're not able to find relevant things. And let's say after like 20, maybe 100 interactions, because you can't put them all into the context window. These models, they do not pay same attention to everywhere, within their prompts. So what you can use is like lifelong or continual learning models, which allow to be able to learn these facts over time, which I'm currently working on. So that you can update these learned facts and you can learn new facts, but still you would need some sort of attention-based models on top of that to be able to understand what is a salient information in a conversation to refer back to later. I don't want to know about where I left my keys until I lost my keys, for instance. This is really, I think it's something that's missing in this grounding to real world and using memory to go along with that.
When you talk about long-term memory, it's a memory of the conversation so far, but also maybe of a previous conversation in a different episode.
Exactly,
right?
definitely. It's not just first, like the conversation so far is really important, but as you said, like if you're having this robot in your house in a daily life, then you want the robot to be able to remember the things that you have told about, like your family members, like what they like, what you like, what are your schedules, or the very little details, but also where your keys are, or like how you like your dishes to be, your laundry to be done, and so on. So it's much more, I think there's still much more work to be done in terms of robotics, not just social robotics, but robotics in general, to be able to apply these LLMs into real world interactions, for them to be useful for us and not just one-time interactions.
Thanks. So what do LLM lacks?
So I think for me at the moment is the multimodality of it all. So I've spoken about the fact that we are pretty okay now in perceiving different modality, different signals and putting them together. But the LLM per se is still very limited in terms of multimodality of the conversational cues. So it's mostly text-based, as Bahar said. So that means that the conversation or the dynamics of the conversation is not fully captured. It's very complicated to be captured and understood and then act upon by an LLM. For example, thinking sight, so again, the vocal burst, so I'm crying, I'm laughing, I'm humming you, I'm being an active listener without really speaking. all of those subtleties are still not fully there, and it's very hard to both perceive them and reproduce them by simply based our conversational systems on LLMs.
Yeah, it's true that these many models are based on pipelines, so when you go back to text, you lose some kind of information. Even if recently, maybe you have seen like this demonstration from QTI, for instance, we did this Moshi system. You can have end-to-end models that capture a bit more than just the message, basically.
The visual language models that are coming up are getting better and better at that, but it's more the how to put them into the dynamic conversation, like the next step on the perception layer, that it's still a lot of work in progress, I think.
Okay.
So yes, and I agree with all what you identified, and I just want to highlight also that historically the approaches for a robot were modular. So you present kind of modular approach, but it was just automatic speech recognition, then dialogue, and the dialogue is now end-to-end. And but before in this dialogue, there were recognition of a lot of events, and then planning, and then generation, and there were these three different stages. And with the arrival of LLMs, this paradigm has changed, and we have all the conversational context and LLM text decision, and we can see in your examples that we cannot explain very well why it takes this decision at this moment, and also for the multimodalities that it's difficult to synchronize all the information and all the information that we can have from the context, also the dynamics of the multimodal dynamics in the context, interspeaker, intraspeaker, intermodality, and so on. And that was done with the previous models, with these modular approaches, and also an explicit way of predicting the next strategy. So we say, what intent should the robot have, and then we generate the text according to this intent. What emotions should the robot display, and then we generate multimodal signals corresponding to these emotions. And so we lose a little bit. So we gain in performance, but we lose in control, I think. And the examples that you show also says that we show that we lack of control. I don't say that before it was better, but but here and we accentuate the robot's lack of social tact in this with using this model also. They have solutions also now, and they are making progress, LLMs, with the safety of the answer. But it's hard also to capture this social context and to have this social tact. And we can see in the thread that this social tact in this turn-taking is not very well done. So and so I think that we should try to do it better now, and maybe to so what we are doing now in our laboratory is to return to modular approach, but integrating the LLMs, and also this is what you also propose to make benefit all what we have in order to improve it. Yes. Mm.
Do you want to react on
Yes,
social
yes.
tact? What?
Yes. So 2 points. So depending on the controllability of these LLMs, for sure. So for the third experiment that I show, we wanted to have ask a certain number of questions in the dilemmas, right? So we wanted to ask about lies in relationships. Is it okay to lie to children? But there's this certain order they should follow. No, it's not going to follow. It's going to ask it in the random order. It's going to do some things. Thankfully, it asks most of the same questions to most people, but not all. And it would sometimes get stuck in some questions. It will just, make up something else. So definitely, we need some for these kind of control experiments. We need something that's like a rule-based system on top of these LLMs that can actually do hybrid systems.
This kind of approach before, the hierarchical task manager.
Exactly.
that were in the dialogue manager before the
Yeah.
LLMs. Yes.
Yeah,
so
yeah,
this is,
definitely.
yeah,
But like with the LLMs, it allows to like generate like an autonomous response, which is great. But we still need something on top of it if we have this very structured conversations, or like for instance task-oriented interactions. On the other point about how we can actually adapt the conversation with these LLMs, because they're failures, right? So with the enjoyment work that I showed, I didn't have time to go into it, but we also looked at like whether LLMs can actually predict the enjoyment without having actually the user's response, so that without the feedback. And they were as good as detecting the enjoyment with the user's feedback, as well as predicting without. So it is possible to adapt the conversation, as what we're working on as well, based on what the robot will be saying, right? So if you let's say you generated something, you ask another LLM, is it this okay? Like, is this a good response? And then the LLM says, you know what? No. And then you can adapt the conversation accordingly, which is really would be a great tool to make sure that we're not doing failures in our interaction, or at least, even if we are, we can recover from them by looking at what was previously said and so on.
It's also interesting what you say about the human sort of social empathetic responses, because that opens up also the question of when and how do we need them to actually happen, in which context, because the context is always very important. So how do we situate an interaction in the context in which we are? What is the data and the information that we need from the task and the people that we're interacting with, and what is appropriate, what is not appropriate in that specific moment, and then how can we make this generalizable in a way, because we can build a system that is perfect for here and now, and then you move it and you want to use it in another place, and then it crumbles because the here and now is not the same, and then you have to start all over again. So how do we make, there's a lot of work also in like transfer learning, task transfer, etc. How do we make these systems really useful in more than just one specific type of scenarios?
Okay, I think we can take some questions from the audience here first. If there are questions related to the discussion we just had or about the talk. Okay, let me pass the mic. Okay, first Fabien and then Gérard.
Laurent?
Yes. Oh, you can? Okay.
Thank you, Laurent. Yeah, just one quick question, because it seems that going from speech to text and then from text to speech is a kind of bottleneck, because you might have some errors and misinterpretation, but at the same time you can guide what is happening. But could we go really fully end-to-end, like you have speech as inputs and the target is speech? So you can learn from that directly. Could it be feasible, and could be also some risks? Because if you take some examples from human conversations or from someone who is not really patient, is always interacting with someone, then you might drive your system to behave the same, which might not be desirable. So yeah.
That's a great question. Yes. Well, current, for instance, O1 is trying to do that, I guess. We don't know how it works, but trying to do end-to-end, so they can generate these speech while at the same time adapting the speech. But the problem is, we don't have data sets with these human-to-human conversations that are actually tagged for robots. There's human-to-human conversations, right? But human-robot conversation or human-robot interaction is different than human-human conversation because of these multimodal cues that I show that kind of affect these failures and everything that affect the conversation. So, for instance, where the turn-taking models, we were combining the voice activity with the text-based, the conversation content. The conversation content model was trained on 3,000. Text-based dialogues, whereas voice activity was trained on 10,000 human-to-human conversations. It's because there doesn't exist a model that actually has both of them, that is big enough to be able to build a general model that can do both of them at the same time. We had to do them separately, but combined their outputs. And even if you do, it's going to be a large model like these O1s and so on, which is if you don't have so many servers, or like if you don't have these thousands of GPUs, it's going to be not a real-time interaction, right? So then you would still need to use these cloud-based systems to be able to have a conversation that is actually a conversation and not like 5 seconds of delay with creating all of these responses. So definitely we should. I think that's how we should go forward. But this additional computational issues, as well as the lack of these data sets, create the problem.
In terms of speech, I really love this idea because it's one of those ways in which you can not only look at the semantic or what has been said, but at how you are saying it. So if you have the speech input, you not only know exactly what has been said, but you know the pitch differences, the influxes, exactly. So all of that information does still a little bit get lost in the models that, for example, I also showed. So it would be very interesting to try and put that as an input directly. Still, in the near future, hope to do it very soon. But yeah, I understand where you come from, and I think it's one of the ways that we can move forward to integrate part of that multimodality that I'm talking about.
Also, like a small comment, like for instance, when we used the 11 labs in the third study, it really was really smooth. It was like a, like a person speaking. And of course, it felt a bit technological, but it had a really, it could give the feeling that a person was saying, all these speech alterations. It was actually doing it well, but there was a lot of pronunciation errors, like saying human instead of saying human, saying human, and that was really annoying in the conversations. But I think some these 11 labs and other like O1 and others are working on it, but and I think it's really important because it changes the whole conversation. If like Amazon Polly is very neutral in the conversation, and it doesn't feel right. It doesn't feel like you're talking. You don't actually want to continue a conversation. I mean, I'm not going to cite a study on that. I'm just going to cite my own self for this. But like, you don't feel like being involved in a conversation. Whereas if it feels like, these changes, like these upbeats or like down when you need to, then it feels real. It really feels real.
So yes, and maybe to be sure to understand what you said, it's what you propose is to go from for example, the speech signals without going to the automatic speech recognition, and then go back to and then synthesize the speech signals. But with the speech, with some words, without going through the semantics, and let all the large language models decide. I think that the lack of social tact will be more present, I would say. Maybe for the interruptions, trying to learn the dynamics flow and how maybe it will have some advantage, but I think that for the semantics, I'm not sure it will work, but maybe I'm pessimistic. And I would like also to mention that this question of going from one modality to another modality also has been done earlier with alignment models, where you, for example, you are doing that. I do the same, or prosodic convergence that we can naturally have, and that's something that, because if I remember well, you have studies also in linguistics that you have also different levels of interactions, and you can also interact directly at the level of the signals. This could be maybe as a way to do, but not the only way to improve, I would say. But maybe I'm too old and pessimistic.
So maybe we can take the question from Gérard, just here.
Yeah, you hear me? So yes, I have a comment and a question. So the comment, I think you have end-to-end models are very nice because it's a way to capture regularities in data. So somehow it's a proxy to analyze data. And so you can perform causal inference and latent space analysis to understand what are the bias, in fact, that shapes the interaction. So my question is not about this, it's about evaluation. We already discussed this during the break, but I think this old concept of perception, control, action that you already mentioned, towards something more end-to-end, more fluent, and so on, it's, how to say, we have to mirror this in the evaluation process. Because it's easy, in fact, to evaluate modules per modules. It's what we have in hands now, it's mainly MOS, so questionnaire, post-hoc. So people perform an interaction with model A and model B, and they say, I prefer A or B. I think we have to make progress on the evaluation, especially if we are concerned about the, how to say, this questionnaire, this opinion is shaped by small events which are going, you know, turn-taking, coordination, and perhaps alignment and all this kind of stuff. So we have to be able to identify online what was going wrong. It's perhaps not wrong always. Sometimes it's just small coordination of events, alignments, which is misleading. And some subjects are just feeling uncomfortable. There are two solutions, in my opinion. One is monitor online, brain activities, skin conductance, and so on, physiological state of the person in interaction with a robot. Second is on evaluation, offline evaluation of videos. So you record, in fact, the interaction, and you ask subjects online. We have been, for example, using yuck response. So you press a space bar each time. When looking at the videos, each time you think something is wrong, and after you can go back and analyze why it was wrong and so on. But so we have to think about new ways, in fact, to evaluate interactive systems. Your opinion about this?
To the second point, we already discussed the first point, but the second point, we actually created the annotation system for the turn taking, for the offline evaluation. So they listen to their own conversations, and for turn by turn, if they felt the robot interrupted them, they actually clicked on it, which was how we understood if there was any interruptions. Because if you use like automatic turn taking failures, so trying to evaluate them, you can see that, you know, like it could work up to a point, but it doesn't feel the same as how a person felt interrupted. So as I said, like the red light was quite interrupting, right? But if you look into the conversations, and a lot of participants noted that after, they said, you know, I actually felt interrupted by the red light, but when I listened to the conversation, and they just listened, they did not see the video, I didn't see that many interruptions because I had stopped speaking because I saw the red light. So it introduces this extra thing, and they said, well, I actually tried to put interruption there because I remember that I actually stopped there. And it was, even though it you know, speech-wise, there is no interruption. So it's important to understand definitely how humans perceive things within their own perceptions. Because if there was done by a third party, then they would go like, oh, this was perfect. You know, they did not know. Even if they looked at the red light, they might have not noticed because the person actually was fully aware of it, and they stopped their own thinking process, which is not visible from a third party perspective.
I think there's a distinction to make between how objectively good a system is and how subjectively it could be good enough for what you wanted to do. And I totally agree, we need better metrics for both. So in terms of using physiological data, in lab, it's a viable option. Of course, you have to be able with the noisy of those data, etc., but we all know it. It becomes less viable if you go outside the lab, if you want to actually have the conversation. Yeah, it always depends on the context of where you are and the people that you're doing the experiment with, so there are a lot of consideration to be taken into that, but it's definitely a viable option. In terms of annotating and looking at, yes, absolutely. The Spring project has created that data set, and we are in the process of annotating and try and see exactly what happens when. And also online, I think it's very important to start having metrics that can, for as much as we can design the system for being right or wrong or doing correct or wrong things in certain points, actually check constantly that something is happening. So LLM hallucination, okay, we can check that that is happening online. We don't need to wait at the end to understand that that is something that has gone wrong. Interruption, we are interrupting in the wrong moment. I know it at that time because we have designed a system in a way that may allow us to have those in-task metrics that then we can use as a proxy to do a first reasoning of what has done wrong while we wait for all the proper annotation and the proper video analysis and etc. to be fully done. And then there is the part of the subjectivity, which I think the physiological data could help a lot in that. And for now, most of the work in HRI is based on questionnaire, which are per se a little bit biased as well, because the question that we are mostly asked is the participant answering on the system, or is the participant asking on you? Because he's in the lab, he's doing an experiment, and he trusts her, he's engaging with the researcher behind the robot, on top of engaging with the robot. So, yes, lots of work to do, totally agree. There are different paths that we can use and that we can integrate in a way. But yeah, that's totally a good point forward, I think. Being able to understand how and when to find a way to measure these systems.
Can I quickly add something?
Sure.
So on the second note, where you can just detect if a conversation is going well or like there's a failure. Right? So the user enjoyment scale that we introduced, that's what we wanted to do, like the turn by turn understand if a user is actually enjoying the conversation. And when we actually looked at it with LLMs to do the prediction, we saw that actually this was possible. So you can actually predict before saying a response if the person is going to enjoy it. But I think that's where like the feedback, like non-intrusive methods, not like watches, but like user feedback, their videos, the multimodal LLMs is actually very important. And like with the work, it showed that they didn't align as much, the multimodal LLM, Gemini, as compared to GPT-4. But the thing is, like, it was better able to explain why a 2 was a 2 than the one that was just text-based, because it saw all of these multimodal features. And I think with Clavel's work, that you can actually look at these multimodal analysis of these, of how people respond to a system. And maybe with our work, you can actually be able to adapt the conversation on the fly without having to introduce other physiological measures as best as you can. Of course, again, it's not going to be the same. What people show and what people feel might not be the same, but it helps. It's better than nothing instead of asking them for so long.
People will agree more on these local events, saying the tone was wrong and so on, than on the global judgment.
Of course.
Your inter-rate agreement is very low. 0.3
Yeah, exactly.
and
It's
so
very
on,
subjective.
because people focus on different aspects of interaction.
100%.
They have different needs and different objectives and so on. But locally, they will agree that something went wrong. So in terms of evaluation, it will be perhaps more constructive and more informal to perform this online evaluation, just a more score or a grid of on multiple. Sometimes you have a multiple questionnaire and you add the 10 questions and you forget about what was the interaction at the end. So just to tell that local scale evaluation is more effective than this old MOS. MOS is old story now.
Yeah.
So all this question of evaluation is super interesting, and maybe even like multimodal LLM can be used as judge for doing some kind of continuous monitoring of this. But maybe we should move to some online question we have, so that people online can also
thank
interact.
you. We don't have an awful lot of time left, but we do have some questions online. The first one that came in, which is more specific, and a second one more general. The first one comes from Paul Gehring, and it's a question for Bahar, which is, do you think your user enjoyment scale could generalize to contexts beyond the HRI data set you used, and will you be studying this in the future?
Yes, it does. So the thing is, I didn't have time to go into it, but like the user enjoyment scale, it was developed on the older adults. But in the paper, we actually show how you can actually generalize this to other contexts. And when we evaluated with the LLMs, we saw that the user perceptions were that the LLMs were actually aligning with user perceptions, again, on this same data set, right? But when we looked into our the second data set, the dilemma, the ethical dilemmas, we saw the results replicate. So they are still able to, the LLMs are still able to detect user enjoyment in correlation with general user perceptions of the conversation. So it can actually go to different contexts. And as you've seen, like the older adult conversations, there was like casual conversations, open domain, from different topics. Whereas the second one, it was more focused on just ethical dilemma conversations. So it could be that it's maybe in education area, it could be a different thing. But there are certain things that if you want to apply it as annotators or using LLMs, maybe you can fine tune your annotation process, the alignment process. So we used 3 videos to align these expert annotators on to develop the scale, and then later validated it. But that alignment process can be adapted with different expert annotators on that field, or by fine-tuning an LLM if it doesn't work. So if you can always just try and see if it works, and maybe in an available data set, and if it doesn't, maybe it's fine-tuning is better, but also it's just good idea to just do it 0 shot to see if it will work in the first place. I think it will, hopefully.
Okay, thank you.
Thank you.
And the next question is from Franziska Babel, and it is, how can we prevent oversharing in LLM dialogues in an ethical but also an acceptable way, not just using a safeguard like, hey, everything we say will be in the cloud?
I guess that's also for me. Yes, so you can't prevent people to share information, which is, I mean, these are like, you want the person to talk to a robot, you actually want them to share something so that it can actually feel like a real conversation, right? But what you can do on the LLM side is to actually do these privacy-preserving machine learning approaches or frameworks that allows to anonymize the data, and also to remove personal information that is that could be going back to the cloud, or there could be going back to the I don't know if the system is hacked and so on, so that they won't be able to identify a person with this information. Because if you want to do personalization, long-term interactions, you need that information. You need the person to tell you something to be able to personalize those interactions. But if you use this these frameworks, like machine unlearning, for instance, is called for forgetting something that should not be in the system. If the person said, "Oh, you know what? Forget that." You know, just like what I just told you. I don't want you to tell this to anyone else. I don't want you to remember this. With the machine learning systems, it's difficult because it's in the training data, right? But the machine learning or knowledge unlearning allows to remove that information without affecting the performance of the system. So there are certain measures that I'll be happy to talk with you about that later. I hope I see you in HRI that we can apply to overcome that, basically.
So yes, I can just complete a little bit about the ethical aspect also, because we haven't discussed it so far. Because there's a question about what should be the role of the robots and the impact of the scenarios that we imagine on a user, and is it a beneficial impact? Is it something that so, because also there were I think it's replica, this, I don't know if you see this, all these conversational agents that were made available to just chatting with people and sharing things. And I would like to mention also the initiative of the COMETS, the Comité d'éthique du CNRS, about the notion of attachment to the robots, and they list a lot of issues and things that we need to look at in order to be sure that we are not going too far in the way we are designing robots, and with that you are designing use cases that are indeed beneficial for the users. And they also mentioned that it's important to work with psychologists, with other disciplines, in order to be sure that we are doing, as a computer scientist, the right things in terms of for this aspect. So does not directly answer to the question, but it's something that we need to highlight at this point of the discussion, I think. Yes.
Yeah, I agree with both. When is technology too much? How can we actually work together with a lot of different disciplines, which we try to do so hard in HRI, and we do it in all of those co-design cycles, because we really, really, really believe that to produce something that is beneficial, we can't just doing it in our silos. So we need to have, as you said, the multidisciplinary approach to what we want to produce and how we want to produce it. And I also agree that we can't control people. Unfortunately, no matter how we try to make the robot as robotic as possible, no matter how you remove all the embodiment, no, it doesn't matter. It's something. People will ascribe something to what you're presenting them, and you can't control what people see in their eyes or what people actually want to do. What we can do is working a lot more on the cybersecurity aspect of things, especially with LLMs, and trying to make everything that happens as safe and secure as possible and as ethically designed as possible. But we can't control the people.
Thanks a lot. I think these are great concluding words. And we have to stop now, unfortunately, because we have to go to NAVER Labs for lunch plus posters plus demo. So thanks to the panelists for the discussion. Thanks to the audience for the questions. And let's go all together to NAVER Labs Europe.